For topic two, we're going to look at determining whether proportions are true. So just because you've been given a mathematical statement that looks like a proportion, it doesn't necessarily mean it's true. So you need to have some skills to understand how to test if a statement really is a true proportion or not. So we're going to recall from something a couple chapters ago. So it says, recall from section 3.2, we learned that we can determine if two fractions were equal by cross multiplying. So I could have said, okay, we have the fraction 2/4 and we want to know, is it really the same thing as 3/6? Okay, so we're like, okay, we have these two fractions, we're saying they're equal, but really, truly, are they? And what we did is we would cross multiply. So that meant we would multiply basically the diagonals. Okay, so the first numerator, second denominator, first denominator, second numerator. And when we did that, for this example right here, I would say, okay, I have 2 times 6. Is that equal to 4 times 3? If the cross products were equal, that told us that our fractions were equal. And in this case, we have 2 times 6 is 12, 4 times 3 is 12. This would have been a true statement. So 2/4 really does equal 3/6, okay? We can essentially do the same thing with proportions because what a proportion is a statement that says two ratios or two rates are equal. And we know that in math, we write ratios and rates as fractions. So to test if a proportion is true or not, we're essentially just testing to see if two fractions are equal. Okay, so again, just to read the statement that I have typed out here a little bit more clearly, from section 3.2, we learned that we determine if two fractions are equal by cross multiplying. If the cross products are equal, then we say the fractions are also equal. Since a proportion is a statement that two ratios or rates are equal and ratios and rates are just fractions, we can use this same process to determine if a proportion is true or not. Okay, so the steps to determine if a proportion is true, cross multiply, and then just essentially compare cross products. So let's look at example 2 here. The directions say determine whether the proportion is true or not. So we are going to cross multiply. So that means multiplying diagonally across our proportion, like I've kind of demonstrated here. So first numerator, second denominator, first denominator, second numerator. So we want to know, is 3 times 8 equal to 6 times 4? Well, if these cross products match, then yes, those two fractions were equal, and we can say that this is a true proportion. Well, 3 times 8 is 24. 6 times 4 is also 24. So we can see here, this is definitely a true statement. So we could say, yes, this is a proportion. Okay. Now, in some cases, it's going to be super obvious, something like 3/6 equals 4/8. That one's easy to check. You could almost just kind of see in your head that this was going to be a true statement. But then we have something like 3.6/6 equals 5.4/8. This one's not as obvious. So we cross multiply again. And we can use our calculator. You are allowed to use calculators at this point as long as you show your setup. You still have to show me your thought process. You're just letting the calculator go in and basically do the side work for you. So please keep that in mind. So what we're testing is 3.6 times 8 equal to 6 times 5.4? If so, we would say that this statement really is a proportion. Okay, so we need to check 3.6 times 8 and 6 times 5.4. So we had 3.6 times 8. We get that that is equal to 28.8. And then we had, I don't remember what the other one was. Let me see. So 6 times 5.4. So we want 6 times 5.4, which is 32.4. So 6 times 5.4 is not equal to 3.6 times 8, which tells me those two fractions were not equal, which means this was not a proportion. So let's see, we had 28.8 and 32.4. So 28.8 and I think it was 32.4. Either way, this is not true. So this is a false statement. So we would say no. This is not a proportion. Okay, so it is a handy thing to know because in a bit we're going to talk about solving a proportion. So what we'll have is we'll have a proportion, and we know a proportion basically is made up of four numbers, two numerators, two denominators. one of those four numbers will be missing. And our job is to figure out what that number has to be to make a true statement. So we need to understand this process here. So don't sleep on this process. It's not the hardest thing you're going to do, and it will definitely come back in just a moment.